Okay, this is part 3 of lesson 1.5, linear system word problems, and these type of word problems are about speed and distance. When we're working with speed and distance word problems, it's really important that we remember the relationship between speed, distance, and time. Speed is equal to distance divided by time. And we can use this relationship to solve for the part of the equation we don't know when we're given information. So let's keep that in mind. Let's look at what we're given. It says a canoeist took 2 hours to travel 12 kilometers down a river. Their return trip against the current took 3 hours. What was the average paddling rate of the canoeist, and what was the speed of the current? Well, there's a lot in this question. Let's look at the journey downstream and upstream separately, and let's get all of our information squared away. That's why I provided this nice table. You don't have to use the table if you're working through the question. It's just a nice way to organize the information. So when we're going down the river, it took 2 hours to go 12 kilometers. So we got 12 kilometers, 2 hours, so the speed was 12 divided by 2, or 6 kilometers per hour. Upstream, same distance, 12, but this time it took 3 hours. So our speed would have been 12 divided by 3, which is 4. Notice we're going slower upstream when we're paddling against the current, and that kind of makes sense because the speed that you're traveling when you're in a canoe going with and against the current has 2 parts. It has your paddling rate and the speed of the current. 2 different parts. I'll highlight it. Paddling rate, speed of the current. Those are the 2 things we don't know. We don't know the speed that you're paddling and the speed of the current. So those are going to be our variables. Let P be paddling speed. And let C be the speed of the current. It makes sense that when we're going downstream, we're going faster because we're paddling at however fast we paddle, and the current's pushing you to make you go faster. Versus when you're going upstream, you're paddling at that same rate, but the water's pushing against you so you don't go as fast. Now you might try to speed up your paddling, but this question assumes that you're just paddling consistently no matter if you're going up or downstream, and it just takes longer because the current's going against you. So how do we solve for the paddling rate and the speed of the current? Well, we use information from downstream and upstream. We can write an equation for downstream, and we can read an equation for upstream. So let's look at downstream first. When you're going downstream, your speed is 6. You're going 6 kilometers an hour. And that comes from 2 places. How much you paddle, plus the current is pushing you as well. So the 2 speeds are working together. Versus when you go upstream, what's happening? Well, we're going slower forward. You're still paddling, but this time the current is subtracting from your speed. You're not going as fast. So these are our 2 equations. We've got 6 equals P plus C, and 4 equals P minus C. So to figure out how fast we're paddling and how fast the current is, we can just do substitution or elimination. So I'm going to stack these equations on top of each other. We've got 6 equals P plus C, and 4 equals P minus C. And we can either add down the columns or subtract. If we subtract, we'll eliminate the P's. If we add, we'll eliminate the C's. So it's up to you. I'm just going to add. 6 plus 4 is 10. P plus P is 2P. C plus negative C is 0. We've eliminated our C's. Divide both sides by 2. We get that P is 5. So now we know our paddling speed is 5, and we can use either equation to figure out our current speed. If the paddling speed's 5, to get to 6, we just have to add 1. If the paddling speed's 5, To get to 4, we have to subtract 1. So our current speed is going to be 1. That one's pretty easy to figure out. But to show my work, I'll say let's sub P equals 5 into, I'll call this my equation 1 and this my equation 2. Let's put it into equation 1. So we've got 6 equals P plus C. P's 5. Subtract 5 from both sides. We get that C is 1. And that's how we can do a speed, distance, and time question. So let's conclude here. Therefore, the paddling speed was 5 kilometers per hour. And current was, wow, ran out of room here, 1 kilometer per hour. That's a terribly squished in concluding sentence. But that's how we do a speed, distance, and time word problem. So I'm going to get you to give it a shot. The next one's about a plane going with the wind and against the wind. So you can set it up, solve for the speeds the same way, write your equations very similarly, substitution or elimination to solve for your speeds. Give that one a shot, and feel free to check your answer on the course website. And that's it for part 3 of linear word problems. And that's actually it for our first unit. So thanks for watching, and I'll see you next unit.